Lesson 9. So only 4 lessons remain here. First one, true or false, explain your reasoning. So why don't you go ahead and answer those 3. Just put a little T or F by it, it'll give you a minute, and be ready to explain to class why you think it's true or false. All right, first one, Ryer. True or false?
I said false.
Why?
Because it's dividing by 3/8 and there's 4/8.
Well, the left side is 8. What's the right side equal?
32 divided by 3.
32 divided by 3. Is 32 divided by 3 8? No. False.
10.6
Thank you. Next one, Matthew. True or false?
True.
True. Left side, you get 50 divided by 5, which is, of course, 10. Jackson. Next one.
True.
Why?
Because 6 plus 4 is 10 times 3. 30 divided by 6 equals 5.
Correct. Both sides equal 5. All right, question 2. It says the other day you wrote sample space for the following. What is the probability of getting? So now it is not asking for sample space. We already did that. It is asking for probability. So do you remember how many possible outcomes we had here? 20. There's 4 in the first one. There's 5 in the second. We said there's 20. We even listed them out here. 20 outcomes. 4 times 5. That means my denominator is 20. So how many different ways could I get green and 3? So again, you could go back and look. How many green and 3s you see here? 1 out of 20. Okay, here's how you can get that. What's the probability of getting a green here? 1 out of 4. What's the probability of getting a 3 here? 1/5. What's 1 over 4 times 1 over 5? 1 over 20. Might be easier than having to write these out each time. Next one. Probability of getting a blue and any odd. So how many blues are there? 1 out of 4. How many odds are there? 1, 3, and 5. That's 3 odds out of 5. So what do you think that one's going to be? 3 out of 20. Can that be reduced? Okay. Cannot. Try this one. Probability of getting any color other than red, and any number other than 2. There you got it. Got to reduce. Molly, how many non-reds do I have?
3.
Out of
4.
how many non-2s do I have, Lauren?
4 and 5.
Now you just multiply it. 3 times 4
12.
over 12 over 20, and you reduce it. Or you can cross cancel. Either way, you need to get the 3 over 5. Okay, always reduce. Always reduce. Question 3, Dieterle.
The other day you looked at a list, a table, and a tree that showed the sample space for a rolling number cube and a flipping coin. Your teacher will assign you one of these three structures to use to answer these questions. Be prepared to explain them.
All right, so what is the probability of getting tails and a 6? Now, we could go back to that chart, but I'm hoping with what we just got done doing, we don't need the chart anymore. What's the probability of getting a tails on a coin?
1/2.
As a fraction.
1/2.
1/2. What's the probability of getting a 6?
1/6.
Okay, so you have two different things we're looking at, flipping a coin and rolling a die. And again, you multiply them to get your answer. So my answer is going to be 1 out of 12. That means if we went back to look, tails and a 6, there would be only one possible outcome that would have a tails and a 6. That would be right down here. It'd be 1 out of 12. So again, you can always make a tree diagram. You can always list the sample space. But if it's all it's asking for is a probability, it's easier than that. You just multiply them together. Next one. Liru, what's the probability of getting a heads on a coin? Trey, probability of getting an odd number on a die.
1/3. Or no. 2. 1/2.
1/2. 3 out of 6, right? 3 odd numbers on a die. You could go 3 out of 6, but I'm going to reduce it right away to 1/2. What's 1/2 times 1/2? Probability is 1/4. All right, most important thing of this lesson is we're going to put a little table on the bottom here. You're going to have quite a few questions that are asking you about rolling 2 die and adding them together. Okay, so a chart is going to show us all the possibilities. How many possibilities do I have rolling 2 dice?
36.
How do you know that?
6 times 6.
6 times 6. If you said 12, again, you're breaking the rule of never add. You multiply. Okay, so I'm going to show you all the possibilities. And a little table here, and you're going to use that to answer the following questions about it, and then this will always come in handy for you. You will see some of these even on your test on Friday and on your final on Tuesday. What is the smallest number you can get when you roll 2 dice and you add them up?
2.
Can you get a number smaller than 2? How many different ways can you get 2?
Snake eyes.
Snake eyes, 1 and 1. Is there any other way to get 2? No. All right, so on this side, label die number 1. And on the top, we're going to label die number 2. And we're going to make 6 columns going down and 6 going across. Okay, now you can write the numbers on there. I'm going to write kind of just what the dice looks like. One through 6 going down, and 1 through 6 going across. And again, what will be nice is once you have this, you will never have to draw it again unless you don't have your book with you. And then you have to make it again. All right, so this is going to show you the possibilities of all the dice. You told me the smallest I can get is 2, rolling a 1 and a 1. Okay, how about if I roll a 2 and then a 1? 3 then a 1. 4 then a 1. And I'm just adding dice together. You see a pattern? Yes?
Yes.
What's the next one start at?
3.
See a pattern? What's the next one start at? That'd be a 1 and a 3, 4. So once you see the pattern, go ahead and just fly through it. And the opposite of snake eyes is boxcars, so the most you can get when you add up the dice is 12. 6 and 6. So are we finishing that up? Has anybody heard of a casino game that involves dice? It's actually called craps, is what it's called. Guess what number the casino wins on? You think they're going to only win 1 out of the 36 times?
7.
The casino wins 1 out of 36 times. No. The casino is going to take the one with the best odds, which would be 7.
Be a good gambler.
Okay? Well, the reason they build casinos is not because you win, it's because they win. So they are always going to take the one that's got the most probability. You can see it's 7. That's the one that's got the most. Most common number if you roll 2 dice is going to be 7. Okay, it should happen 1, 2, 3, 4, 5, 6 times out of 36. 1 out of 6 times, you should get a 7. All right. So we are going to answer these questions now, and you're going to use this chart to help you. We'll do one together. Now maybe we'll do a couple together and let you try the rest. Both cubes show the same number.
1 out of 6.
So how many different times can you have the same number? Well, I could roll a 1 and a 1, 2 and a 2, 3 and a 3, 4 and a 4, 5 and a 5, 6 and a 6. That's a total of 6 out of, how many boxes do I got? And then you reduce. 1 out of 6 times you will roll 2 dice and get the same number. Okay, let's do B as well. Exactly 1 cube shows an even number. Only 1 dice shows an even number. All right, well, let's look. Is 1 and 1 an even number?
Yeah.
Does one of the dice an even number?
Yes.
No, it's 1 and 1. Neither one of those are even.
Oh, well, added together.
Okay, exactly 1 cube shows an even number. Doesn't say anything about the sum. We're not adding anything. Okay, how about a 2 and a 1? Is that exactly 1 cube showing an even number? Yeah, how about this one? How about this one?
Yes.
That's 2 even numbers. Is that exactly 1? No. Yeah, no. Yeah, no.
No, yes. No,
See a pattern?
no. Yes.
See a pattern?
Yes.
How many?
Half of 36. Half of 36.
I already circled all the 7s, but half the time. Makes sense. Half the time you'll get 1 even number. Yeah, it would have been 18 out of 36 if we reduce it to 1/2.
What's that mean?
Roof is falling in.
Oh, we should get a.
All right, why don't you try C, D, and E? C, D, and E. Try them. Use that chart. Anybody need more time?
Yeah, just a little bit.
Okay, give you another minute. All right. At least one cube shows an even number. So at least one cube. So here they would all have even numbers, right? Here, here, as well as going straight down, straight down, straight down. And I don't want to draw marks all over your, I guess this one I can. Don't draw marks all over yours. You could circle them again, square them. Okay, so it might be easier to see how many are not included. 1, 2, 3, 4, 5, 6, 7, 8, 9 are not included. So how many are included?
27.
27 out of 36, which reduces to?
27 out of 36.
Okay, what is it?
27 out of 36.
Reduce it for me. Because you told me it reduces to a number. Reduce it for me. It does reduce. So we'll wait. What goes into 27 and 36? Don't want to just pick a number? Don't want to just pick a number and try it? Try 2. Does 2 work?
No.
Okay, so try 3. Deedly, 27 divided by 3. We don't need a calculator for that.
7 over 12.
27 divided by 3. Trey.
3. Oh, never mind. I had 3 over 4.
Divide by 3. Divide by 3. And now it can go further.
That's what I did.
Divide by 3 again. Now Trey, divide by 3.
One step ahead. 3/4.
Yes. Could have divided by 9 right away. Okay. Questions where this chart will really help you? D. How many different ways can you get a sum of 8? Cameron, how many sums of 8 do you see? 5. There's 5 8s in our chart. Out of 36, can that be reduced? No. Last one, Cruz. 2 values that have the sum of 13. Trey.
I didn't get that one either.
Yes.
Wait, no. That's 0.
There are no 13s in a chart, guys.
Oh.
It is 0. It cannot happen. That was the easiest one, right?
Yes.
You can't roll 2 dice and get a 13. Next one. I'll give you a minute to see if you can get that guy. You should not need to draw the sample space. But if you do need it, we already drew it for you on Friday. Remember, the denominator is always the number of possibilities. Parker, what's our denominator?
8.
8. Why?
Because half of the half is 1/4 and half of the 4th is
3 coins, all with 2 options. Denominator is 8. How many different ways can you get the same thing on flipped up? 7? How many different ways can you get the same thing flipped up? Leerud, can you give me one that all the same thing is flipped up? can't give me an option where all of them would be the same. You're flipping a coin.
I don't know.
Jada. Yes, you could get all heads. They're all the same. That's all I was asking. Can you give me another way, Jada? You could get 3 tails. Is there any other way to get the same thing up? No, so how many is that? 2. There's 2 ways. And then you reduce. 1/4. Now again, we listed them all right here. We already did this problem. How many of them were all the same? 2 out of 8. It's the same problem. All heads or all tails. Question number 4. Dakota, would you read that, please?
Imagine there are 5 cards. Red card, red, yellow, green, white, and black. You mix up the cards and select one of them without looking. Then, without putting that card back, you mix up the remaining cards and select another one.
All right, so here's the key. Whatever you draw, you do not put back. First question we've had like this. Okay, that means if you draw a red card, you cannot draw a red card again because you're not putting it back. Okay, so super important. You gotta look for that. Sometimes it'll say without replacement. That means you're not placing it back in there. So we need to write the sample space. First, tell me how many possible outcomes we have. Raise your hand if you know. Yes. No. Drawn 2 cards, remember. Lauren? 25 would be right if you put the card back in.
10,
Not 10.
24,
No. 20. How many cards can you possibly draw the first time? Now you're not putting 1 card back in there. How many cards can you draw the second time? There's 4 cards left. 5 times 4, 20 outcomes. Now I need to list the sample space. We've done tree diagram, we've done list, we've done tables. Which way would you like to do it?
Tree.
Okay, who wants a list? And it looks like a majority. Okay, so if I draw a red first, what is possibility for my second cards? Yellow, or I could draw a red, then a green. I could draw a red, then a white, or I could draw a red, then a black. Agree with that? Why can't I put RR? You are not putting the card back in. That will drastically change your answer, so you got to pay attention to that. Okay, which other one could I draw first? Yellow. So I could draw yellow, then a red, yellow, then a yellow, then a, and yellow, black. What else could I draw first? Green. Green, red, green, yellow, green, white, green, black. Could draw white first. White, red, white, yellow, white, green, white, black. And the last one, I could draw black and then red, black and then yellow, black then green, black and white. And again, you should have 20, and none of the letters would be the same. If you could draw out the same color, how many options should you have? Should be 25. It'd be 5 options both times. And then you'd have to include red, red, yellow, yellow, green, green, white, white, black, black. But you're not putting it back in there. Okay, which structure did we use to make it? List. Why? Yeah, that was the most common vote, I guess. So now let's use that sample space to help us out. Jackson, white card, and a red card in either order. Either order, white and red, red, white. How many ways do you see that listed there? 2. Red, white, white, red. There's 2 out of the 20. Reduce it. 1 out of 10. 1 out of 10. B, that you will get a black card either time. So look for any of them that have a B in it. Lauren. I got more than 6 with B's. Cameron. 8. 1, 2, 3, 4, 5, 6, 7, 8 have a B in there. Then, of course, we reduce.
4 out of 10 and then 2 out of 5.
Correct. C, that you will not get a black. Well, this was getting a black, so the other one would be the opposite of that, right? 12 out of 20, which reduces 2. Which reduces 2.
3 out of 5.
Yes. All right, I would like you to answer the last 3 from the same chart. Okay, it shouldn't take long. Trey, probability of getting a blue card. 0. There is no blue cards. What did you have written down? No, you certainly had something. Just curious because there's no blue ones. Wonder what the other possibility is. Nothing? No comment. E, 2 cards of the same color, Cruz. Yeah, we said that can't happen. You're not putting the card back in there. Impossible. 2 cards of different colors.
20 out of 10.
How do I show that? Which reduces to?
1.
Remember, 1 means always happens, 0 means never happens. Okay, just like our Desmos quiz last Friday. Okay, take a look at homework problems. Starting on page 76, question 1. Talking about a vending machine. 1 has colors, 1 has animals. What's the probability of getting a yellow gumball and a lion? I think you can answer that one quite easily. 2's probability. 3's probability. Make sure you explain number 3. That one, make sure you read the question on that one. Question number 4, write the sample space. Underline that. That means we need to list it out and tell how many outcomes there are. I like to do the outcomes first so I know how many answers I should have. Rolling the dice and flipping a coin, we've already done that. You have that listed somewhere. Yeah, you have that in your notes somewhere. We did that. And do the same for B. We haven't done this one. You're selecting a month and then picking a year. List all the outcomes. Again, if you want to do tree diagram or table or list, up to you. Question number 5, again, not a big fan of how they have this one formatted. Draw an arrow, it's on the next page. Add some more, put a big 3 by that. I want 3 points on this graph. Let's talk about it. Let's pick one. So somebody give me a side length, nice side length that we can graph.
4. 6.
Okay, how about we start with an easy number like 2? You don't have to get so drastic here. The side length is 2. What's the perimeter of that square?
8,
What's the area?
4,
2 times 2 is 4, right? So that's the point I'm graphing. Perimeter is 8. Area is 4. And then I'm going to label it 8, 4. So you need to do that 2 more times. Pick whatever sides you want for the square. Make sure it fits on the graph. And then it's saying, is it proportional? And explain why or why not. Make sure you explain why or why not.